All right, so today we're going to continue on with using trigonometry to help us find the sides and angles of triangles. We're also going to continue on working with triangles that are no longer right. So that started with our 12.4 lesson over the law of sines. Today we're going to learn the law of cosines, which expands our ability to find different angles and or side measures depending on what we know. So first, there are three versions of this. You're going to choose one, but let's go ahead and write those in. Now, based on a triangle ABC, the first version of our law of cosines is a squared. Let me go a little thinner. A squared equals b squared plus c squared. Kind of a little bit of a Pythagorean theorem look there. Minus 2bc times the cosine of angle A. So as a reminder, just about the way in which to read this, remember that when we use lowercase letters, we're referring to side lengths. So you'll see here up in the information, sides are A, B, and C. So just kind of remember that if you see a lowercase letter, especially if it's not an A or B or C, because the book does like to change that up, we're referring to a side. When we use our uppercase letters, that's when we're referring to the angles or the vertices in the triangle. So this particular equation, it would be used if you were trying to find side A or trying to find angle A. So the different versions of our law of cosines is just based on which side of the triangle you're trying to find. So if we were trying to find side B, we would use b squared equals, and then we adjust the placement of our items. So if b squared is what we're trying to find, then it would be a squared plus c squared minus 2ac times the cosine, and this one uses angle B. And then, of course, since this is a triangle, we have a third side option. So if we were trying to find side C or angle C, we would say c squared equals a squared plus b squared minus 2 times a times b times the cosine of angle C. So there's your three options. You'll never use more than one. So every time we start a problem, our goal is to choose one. Now, to help you with the process of knowing when to use the law of cosines versus the law of sines that we have already covered. So, the two instances when the law of cosines is of best use is first, if you know two sides and an included angle, which we'll redefine today so you know which angles those are. Law of cosines is also helpful when you know all three side lengths, or just sides. All right, so there we're going to first focus on how do we find a missing side. Then I'm going to record a separate video to assist us on how to find a missing angle. So let's start with our sides. Here we have triangle ABC. So as a reminder, if vertex A is located here, that means that side A is located opposite of that on the side that does not touch that vertex. And in this particular problem or example, we're told that this is 7. We also know that side C, which sits opposite that vertice, is 12. So there's the side lengths, and they're labeled. We also know that angle B is 41. Now, so let's get back to that wording, included angle. So let me highlight the sides we know. We know side C, or AB here, which is technically the C that equals 12. We also know the side here between B and C, which is A equals 7. Since they meet at vertice B, we would call this angle here the included angle because it is between the two sides that we know. So that's how you can determine that you have the information you need to use the law of cosines. So the side we are going to try and find here is this over here. So you can just say it's little b, or if you want to use x, it's up to you. So of our three options above, since we're looking for little b, we're going to go ahead and choose this one that I have here marked in B, or sorry, in blue. That will be the equation we need to use. So all of the triangles in your homework are already labeled. So your first step is really just to choose which of the options as far as law of cosines should you use, or just those variables depending on the variables the problem uses. All right, now let's go ahead and substitute what we know. So we do not know b, so I'm just going to leave it as b squared. A is 7. We're also going to square that one. Plus C, which we know is 12. Minus 2 times, so we're going to use A again, which is 7. We're going to use C again, which is 12. Times the cosine of angle B, which we know is 41. As a heads up, you'll know you've picked the right version of the law of cosines that if after you've substituted, all you have left is this variable over here to solve for. Now, solving for side is actually quite simple. So before we do any calculations, we know that the inverse of squaring something is to take a square root. So what we like to do so that we can get b by itself is we're going to take the square root of both sides. And I'm doing this now instead of later because we can enter this all into the calculator at one time. So in our calculator, which I'm going to flip to here, we're going to enter in the square root of, and we're going to enter in this entire radicand here that we see. So let me switch over to my Desmos. Now remember, we want to make sure that we're in degrees. So if you're using Desmos, make sure you have it set to degrees. So first we're going to type in the square root symbol. If you want to use parentheses, feel free, but I'm pretty sure in Desmos it'll just continue covering. If you're on an actual calculator, I believe it does open up a parenthesis to make sure it knows everything that's going underneath your square root symbol. So we have 7 squared plus 12 squared minus 2 times 7 times 12 times, so remember to get to sine, cosine, and tangent, we hit this functions button over on the right. So we're going to select the cosine and then 41. End our parenthesis. And we should get an answer of 8.14. And we're going to go nearest hundredth. So 8.14 is the length of our missing side, or side B. And that is how you find the side length using the law of cosines in a triangle that is not a right triangle. So again, like before, example 2 is a lot of the same. So if you'd like to pause it here and try to work example 2 out before you see the result, and then go ahead and play it and see if you've done it right, that'd be a great way to check to see if you're understanding. So again, we're going to label our parts. I'm going to try and keep my colors the same. We know that angle B is 36 degrees. We know that side C is 6. We know that side A is 7. We're noting that this is indeed the included angle. So law of cosines will work. And then we're going to sub in. So I already used the same one from the first problem. So I'm just going to copy and paste that down. And now we need to substitute. So we're trying to find B. So B squared equals A, which in this particular case is 7. Plus C, which for this problem is 6. Let me do this so I don't have to keep zooming out. Minus 2 times, we're going to use A again, so 7. Then C again, which is 6, times the cosine of our angle, which is 36 degrees. Now I've purposely tried to color code it so the parts that show up every time are in black, including the item that we're trying to solve for. All right, we know that eventually to get B by itself, we're going to take the square root, so we're going to go ahead and do that right now so that we can just enter this into our calculator all at once. So B is approximately equal to, and I'm going to swap over to my Desmos. And since I haven't exited out, it should still be in degrees. So we have the square root of 7 squared plus 6 squared minus 2 times 7 times 6 times the cosine of 36. And we should get that the side length is 4.13. And that ends using the law of cosines to assist us with finding a missing side.